You've probably heard it a million times. We live in the age of data. And almost all of that data, from the smallest spreadsheet to the biggest corporate database, lives in a simple table, with neat rows and columns. It's the foundation of everything.
I mean, it just seems obvious, doesn't it? A basic fact of our digital world. Well, maybe it's not that simple. What if that structure we depend on to keep things organized is actually setting us up for chaos? What if it's the very thing that can corrupt our information or even make it vanish completely?
Okay, let's dive right in with a pretty straightforward example. Here we've got a table called EMP. It's for tracking employees. You've got their employee number, their name, title, salary, and then over here you have info about the projects they're on, like the project number and what their responsibility is. Seems totally logical, right? All right, before we start pulling this apart, let's just get a couple of terms straight. In the world of databases, a table like this has a formal name, a relation, and each of those columns, like ename for the employee's name or sal for salary, is called an attribute.
And finally, each individual row, which is a single complete record, is called a tuple. So we've got our relation, our attributes, and our tuples. It all looks so perfectly organized, but believe me, it's a house of cards.
Because hidden inside this simple design are some major flaws. They create these nasty little glitches that are just waiting to cause all kinds of trouble. Let's call them the data gremlins. So let's meet gremlin number 1. This one is called the repetition anomaly, and it's all about saying the same thing over and over and over again. Just look here at M. Smith. Her employee number, her name, her title, her salary. It's all listed once for project P1. And then, boom, it's all repeated again for project P2. Same exact thing for A. Lee. Now, you might be thinking this is just a little inefficient, but it's way more than just wasted space. It's a trap. And it's setting us up perfectly for our next gremlin.
And this is where that trap springs. It's called the update anomaly. And it comes back to bite you the second you try to change any of that repeated information.
So imagine M. Smith gets a raise. Awesome for her. Someone goes into the database and updates her salary in the system, but they only change it for one of her projects. They miss the other row. And just like that, our database is broken. It's now telling us two completely different stories. Which salary is the right one? Who knows? The data is now fundamentally unreliable. And seriously, just think about this on a bigger scale. In a huge database with thousands of employees working on dozens of different projects, how could you ever be 100% sure you've found and fixed every single copy of that one piece of data? The truth is, you can't. It's a disaster waiting to happen. All right, on to gremlin number 3. This is the insertion anomaly. This one is just bizarre. It can actually stop you from adding new, perfectly valid information into your system. It's kind of like having a filing cabinet that won't let you create a new empty folder. Here's how it plays out. Let's say the company is planning a brand new project. We'll call it Project P5, and they want to log it in the database. You'd think that'd be simple, right? Wrong. With this table design, it's actually impossible. Why? Because the table is structured so that every single row has to have an employee attached to it. But this project is brand new. No one's been assigned to it yet. So you just can't add it. The information literally has no place to live. And this brings us to our final and maybe our most dangerous gremlin. This one's called the deletion anomaly. It doesn't just corrupt your data, it can make it vanish into thin air. Take a look at Jay Miller. He's a programmer on Project P2. Now, what happens if Jay Miller leaves the company? The logical step is to delete his record from the table. But hold on a second. Notice that he is the only person working on Project P2. So if we delete his row, we don't just lose the information about Jay Miller, we lose everything about Project P2. The fact that it even exists just gets wiped out. We've accidentally destroyed critical company data. So our table is a mess. It's redundant, it's inconsistent, and it's super fragile. So how do we fix it? How do we exercise these data gremlins? The solution is to perform a kind of grand tidy-up. The formal name for this tidying process is normalization. Now, the technical definition sounds a bit academic, a process of concept separation. But what that really means is super simple.
Don't store unrelated facts in the same place. Facts about an employee are one thing. Facts about a project are a totally different thing. You shouldn't mix them up in the same table. And this shows you the fix beautifully. On the left, you see the mess we started with, that one big table trying to do everything at once. And on the right, you see the solution. We break it into two smaller, cleaner tables. The EMP table now only holds facts about employees, and a new proj table only holds facts about who was working on which project. Each table now has one clear purpose, and it does it well. The process itself is really logical. First, you look for the different concepts that have been all jumbled together. In our example, it was employee info and project info. Second, you separate them out into their own dedicated tables. And third, and this is the critical part, you create simple links between them, like the employee and project IDs, so you can still connect the dots and get the full picture when you need to. Now, the secret sauce that makes all this work is a principle called functional dependency. It sounds complicated, but the idea is actually very intuitive. It's just a rule that helps you figure out which facts belong together. You simply ask yourself, if I know one thing, does it absolutely guarantee that I know another? So for instance, if you know an employee ID, do you know that employee's name? Yes, you do. The ID determines the name. But does that same ID determine the project they work on? No, they could be on several. That is the logic we use to split the tables. We group the things that determine each other. And this whole tidying process comes with 3 crucial guarantees. First, you can always join those smaller tables back together to reconstruct the original with picture. Second, all the original rules and relationships are perfectly preserved. And third, and this is the most important part, absolutely no information gets lost in the process. You're not deleting data, you're just reorganizing it to make it more robust, basically to make it gremlin-proof. This might feel like a pretty technical detail, but it is the absolute bedrock of our modern digital world. Everything from your bank balance to your medical records relies on well-designed, normalized data. It really makes you stop and think, doesn't it? In a world that is so completely built on data in tables, what are the real-world consequences when a single, poorly designed row goes wrong?